working in a project with development mode, working in a project in a kind of feature maintainability mode. Feature maintainability in the sense that kind of enhancement or bug fixing is software is available. Whereas in development, software is not available. Someone is developing the software from the scratch. So in development mode, a developer need to include many libraries. Where in maintainability code, the developer has the software. So in both cases, a developer needs to know about the either library package or the current software. If we see Python is kind of loosely, or it doesn't have any explicit type, function signature, class attributes, module attributes, wherever you see. The variable they do not have type, means Python understands and it instantiates the typing implicitly. Programmer can explicitly declare a variable, but not required. Means there are kind of notations through which, like if it is double quote, then it is a string. Otherwise, if it is kind of a decimal number, then it is an integer or it is a float. So problem is, so if I am developing a software or I am kind of maintaining a software, how I should proceed? That is a big task. One work is that I can go ahead and I can just look at the library package if I am developing, or if I am maintaining the current software packages and source code and class code. It's a multi 10,000 lines of code that I need to understand before I start. It takes months. Like any widget programming, if I need to use a widget, then I'll go with the widget class, then search here and there, all the derived classes, then think about its kind of usability, means which widget I should use. In Python, adding to a class data structure or adding an attribute to the class instance is runtime. You can add in any methods, in any function. You can kind of grow your class data structure, class instance data structure. Reading code is kind of cumbersome. So what is the solution? Solution is that I should know the design of the library package or design of the current package in advance. If I have the design package, means kind of package diagram or class diagram, inter-class diagram, inter-package diagram. So these are called kind of UML schematic diagram or kind of architectural diagram. So rather than going inside the code and picking here and there, it's very nice that if I start my work, rather than investing weeks or months in understanding code here and there, we can have a kind of architecture in the hand. I can take printout of the architecture. I can just browse on my mobile. So if I need a particular class to be used, just I can browse the class diagram, inter-class diagram. Inside the class, if I narrow down in few classes, I can just browse through the attributes and its methods, and I can decide, okay, so at this place, this class, I need to instantiate. So class diagram, package diagram, I need to have in my hand. So how I can proceed? I am writing a code, library package or the current software architecture, how I can do it? I have Python source code. Python source code is not a big deal. Means if I install a software in Python source codes are available. I mean, they only execute. Or if software includes a shared library, then Python code means for famous library, anyway it is available on GitHub code repository or something. So getting a source code in Python is not a kind of a big issue. So if I have a Python source code, a solution is there any tool or software that would kind of parse the Python code and give me the architecture? I did not go all the places and see that if someone is attached to self or someone is attached to the class data structure or something like that. It's not C++, where the initialization generally happens in the constructor or something. Anywhere kind of attribute initialization or attribute addition can happen. So if I get to have the architecture of the class of the library package or the current package, it is a kind of a boom. Means you can start immediately if you have the blueprint of the architecture. So we'll see the PyReverse tool that parses the Python code and then it generates the kind of the architectural blueprint, package diagram, class diagram, inter-class relationship, everything is there. There are few things that is lacking in PyReverse. Like for in a class diagram, we don't have the derived classes, only the kind of parent classes are there. Kind of, we can have our own software that uses the PyReverse, and whatever is lacking, that you can fill in. Just run the tool in 1 hour, 2 hours, full architecture is there. Just use the architecture kind of in PDF format or something. You can just, when you are free, you can just sit and browse the architecture. Start using. So we'll see that how in reverse engineering we can generate the UML architecture, class diagram, package diagram, and interrelationship through PyReverse and any tool that is using the PyReverse. That means. In continuation to the discussion on generating UML diagram from the Python code through PyReverse tool. So we'll proceed on a package called MySQLdb that is used for connecting MySQL database and manipulating the data. This is Linux Mint. Okay, so first kind of we'll brief about the tool, then we'll proceed on MySQLdb. So PyReverse is a kind of available tool on Ubuntu through Package Manager, and it draws a UML class diagram, it draws a package and module diagram, inter-class relationship inside a class, then its attribute and methods, package and module. So inter-package relationship. So in package diagram, modules are also being drawn, and then modeling elements that are mainly used inside the class diagram, like generalize for inheritance and realization of interface, containment, aggregation and composition. So kind of loose composition is aggregation, tightly is composition. Okay, so whole life, if kind of the container goes away, then contained object also goes away, but that is not the case in aggregation. Dependency, if one class calls any method from other class, then dependency kind of is assigned. Association is when one class is related to other class, but it's not a dependency. Okay, like one student is associated with kind of many organizations. It is not dependent upon the organization. Okay, so installing the PyReverse, PyLint is the package, can be installed through apt-get, that is package manager, or through PIP. Okay, so we'll talk about MySQLdb. So MySQLdb can be installed through Python 3 MySQLdb sudo apt-get. Okay, MySQLdb repository, the code repository can be fetched from Git hub. Okay, later we can check the versions. PyReverse, all commands available can be kind of it can be checked, it can be verified through -h, available through -h, -h. Okay, so PyReverse mainly it takes module list or package directory as argument, and then how many level of ancestors we want, that is inheritance, how many level of containment we want, that is kind of association, and if we want to print module in full path name, yes or no, -k only class name, -c if we specify a particular class, full attribute and methods are listed, -a small a number of level of ancestor, -s number of level of association, like that. Okay, so if Python package is available in a directory, then that directory must be in Python path. Okay, that is the idea. Now, in kind of okay, so more on it that we'll see. Okay, so probably this we can see after the installation process. So that is kind of a lab session. Okay, so we'll install through PyLint. Okay, so we'll say kind of sudo apt-get install PyLint. It is already installed. Sudo apt-get install PyGraphviz package also will install. It is already installed, and we need to install Python 3 MySQLdb. Sudo apt-get Python 3 MySQLdb. Okay, so all are already installed. So I can say dpkg -l e grep -e and PyLint graphviz and Python 3 MySQLdb. Okay, so these are the version 2.42, 2.12 and 1.46. So these are the version that is installed. Now we'll see PyReverse -h. So I can say PyReverse -h. Okay, so minus F is a filter mode. What attribute we want, public only or all or whatsoever. So pub only is the kind of current one. Minus C for class, minus A for ancestor, minus S for association, minus B if we want built-ins also, minus M for module name, complete name means Y. Okay, minus K only class name, only skeleton, minus O what is the type of the output format, PDF, PNG, dot, if you want colorized output. How many level of colorization? Because if level differ, one class is inheriting other class and so here and there. If level differ, then color changes. How many level of depth we want? If you want to ignore some files, so files or directories can be skipped. Okay, if we want to set a project name and what is the output directory, where the output would go. So this is the scenario. Now, how it draws package diagram, and that we'll see. Okay, so inside the package diagram, we can see that like if I have a code like this, where there is a base directory called base, and inside that there is a directory called package 1, inside that package 2, and inside package 2 we have init, so init file is everywhere, and inside package 2 we have module 2, and inside package 1 we have module 1. So if this is the code, so kind of this is a cat on each file, and if this is the code, then this would be kind of a package diagram, where kind of so this is a dependency. Okay, this is not a kind of a containment that in base these packages are available and whatsoever. So base is depend upon these packages. Okay, module 2, package 1, package 2, module 2, package 2. Where is package and package 1? Package 1 depend upon package 2 and module 1. Package 2 is depend upon module 2 inside the package 2 and module 1 inside the package 1. So this is the kind of hierarchy, dependency hierarchy. So that we get in package diagram. Whereas if there are 3 classes, one class is in package 1 module 1, and package 2 module 2b, and package 1 module 1b derives from it. So this is the class diagram I would get from this code, and this is the kind of package diagram that I get. Okay, so we'll see each level kind of will generate package diagram, will generate sub package diagram, and will generate module diagram. So all 3 levels. So typically in Python code, hierarchy is like this. If I have a root package, it has sub packages and module. Okay. A sub package can have another sub package and modules, or a sub package can have only modules. So module is the end one. Beyond that, nothing can happen. It's a file. Whereas package are directories. So one sub package contains another sub package directory and modules. Okay, so this is a kind of a recursive diagram. Okay, so we'll see a little bit about the MySQLdb. So MySQLdb is a database, and it can be remote also, not present on particular computer, particular machine, particular hardware, and it can be connected from remote. So mainly there are 2 classes. One class is connection, and connection makes a connection. So like function can be connect, close cursor typically, typically it connects in the constructor only. Okay, so connect would connect, close would close the connection, cursor would get the cursor of the connection, and through cursor we can execute the SQL APIs. So once cursor is received, then it can start executing the SQL APIs on the MySQLdb. So it does connect, close, and whatever is connected it can close, and it returns cursor. There may be others. So this is the primary. So this is kind of overview of MySQLdb. Now we will proceed on generating the diagram. Okay, so we'll start with kind of this is the kind of PyReverse diagram generation. So what we can do is we can create a directory mkdir reverse MySQLdb. Okay, now it's pretty simple. That will proceed now. Whatever we see, we will see. So it's an empty directory. Now we'll see where package is installed. Okay, so package is installed in user lib Python 3 dist packages, and this is the package name MySQLdb, and beyond that files are there. Second thing is Python path must be set in the package directory. So if this is the package directory, this Python name, Python path must be set. Okay, so I can just say kind of export Python path user lib Python 3 and dist packages. So this is one way. Other way, we will check if it is not already set. So I can just print okay, so print Python C import sys and print sys dot path. Okay, so whatever path we wanted, usually Python 3 dist package, it's available. Nothing to be done in this case. Otherwise, we need to set like that. Okay, so there is nothing. We have not done anything. So we'll start with kind of the way we talked. Okay, so we'll start with the top package and we'll see sub packages and module. So we'll see what is available there. User lib Python 3 dist package MySQLdb. Okay, there is a one sub package called constants. Okay, and there are few files there. So this is what we are saying. So the top package is MySQLdb. Top package is MySQLdb, and constant is sub package. Whereas in MySQLdb there are modules like init.py, cursor.py, connections.py. In constant sub package, and again there are files, modules. So kind of this verifies the architecture what we are talking about. Okay, so we will start. So PyReverse is the command, and then we will say what we want package. So here, and then MySQLdb, this package, all ancestors, all associations. It's a very small one. Okay, nothing much, and output format would be PDF. Okay. Done. So there are two files now. One is package diagram. So this is so neatly it is drawing. Amazing. Means if someone kind of starting the work in MySQLdb, it is worth to see this diagram. Now MySQLdb is depend upon constant and release, and then it is depend upon the connection. Connection internally again depend upon the MySQLdb. MySQLdb depend upon the times and so. Means mind blowing. So nice. Means if someone is starting the work, it is worth generating this. Kind of it gives the concept of the, okay. So whatever we see here, it is a kind of output of, if I print this file, user lib python 3 dist mysqldb, and if I say init.py, now we'll see from, these are the code from mysql.db.release, import this. From MySQLdb, compat, constant, times. So this code in the file lead to the kind of generation of this diagram, MySQLdb release. We saw that. And then compat and constants and time, MySQL release. Okay. Times. Constants. So there would be constants. Here it is. Okay, so from constant. So this is what we are kind of seeing. So the way it is mentioned in the init file, this is the way. Now in the connections init file, it would be kind of it would be depend upon the compat, and then it is depend upon the constants. So the way it is written, it is happening like that. Okay, so that is the scenario. I can browse that file also. Okay, MySQLdb compat is there. So this is the way it is drawing. Okay, MySQLdb directly depend upon compat also. There is arrow. Okay, so we are kind of we are understanding why how the package diagram is being drawn. Next is class diagram. This is the class diagram. Top class. Okay. So class diagram means all classes in a package, all classes in package, and their interrelationship. Like the main class is connection class, the way we talk, and connection class has these many attributes and these many methods. Okay, there is a method called cursor. Okay, connection class derives from a class that is available in C file, means through SO file it is. So that is not caught here. We have modified version, so that also will proceed on that. Okay, whatsoever. So it provide cursor class. Cursor return the cursor. I think people who know MySQLdb. So now cursor, which is derived from base cursor, and it provides like execute. So SQL queries can be executed. So this is the kind of a class diagram in a package. More neatly we can draw. Okay, so kind of I can say whatever the command we executed, I can say colorized. Okay, so package diagram got colorized. As we can see, automatically it updated. Class diagram also got colorized. So this is in color format. Now there is a show built-in, then built-in should also come. Okay, no change in package diagram, whereas Mr. Class diagram would change. So along with built-in, so these are kind of means this class diagram is not of much use if we want built-in, because there are too many. Okay, if we want only a skeleton, -k. Okay, no change in package diagram. Class diagram would change drastically, and only classes are available. Properties and methods are gone. Only class names are there. So this is kind of what we get. Now we talked about sub package. So we saw the package diagram. So if I want sub package, then I'll remove -k and show built-in and colorized. I think we are done with this. And here I can say constants. I can remove kind of everything before I try. So it would be kind of more realistic. Now I have again two packages. So this is about at constant level. Okay, there is nothing. So there is no class in the constant. So absolutely there is nothing. So this is kind of a sub package diagram. If we want a module diagram, then here we can provide the module name. Like if I want for connection, I'll remove everything. It's empty. Connections. Now it is generating for module. So we are here now in the third arrow. So at the module diagram. So at module only we get class diagram, and it's there. Okay. So few classes are missing. What we saw at package level, certainly it is less. And whatever is available in the connection.py, there are 5 classes. It is showing relationship between. So at level of package, at level of sub packages, at level of module, we can generate package diagram and class diagram. So if I provide -k, then only class name would come. Okay. So now it is not mentioned here. So down in the module, we can generate at the class level. So I think I can update this. Okay, so now inside the module we have class. Okay, so module would contain a class. Okay, so now we will see at the class level. we will see at class level. Okay, so this is what I am saying. Now we will see at class level. So package level, sub package level, module level. Now we will see at class level. So we already have this, so we will remove, nothing is there. Now we will say PyReverse minus ASMY and user live Python 3 and MySQLdb connections .py minus class connection. Okay, minus O PDF colorized whatsoever. I may not put this also. We'll try. It's done. Okay, so this is the connection diagram. So since connection and all the classes what we saw in the connection.py, so it is drawing everything there. Okay, so this is kind of a per class basis. Okay, so what we saw is we can try with kind of built-ins if we want. Okay, so this is with built-ins. Okay, so we covered PyReverse. Now there are few limitations that we can see. First thing is, if we want through built-ins, it is too big. Unnecessarily, like if there is a base cursor, then there is a none type, and too many containments are being shown, unnecessarily bloating the diagram. And other problem is it shows too many classes for the built-in. Every class we have a property and method that we don't want. Or if I specify minus k, then nothing will come. So this is the kind of a problem. There won't be anything, only class name would appear. Okay, so this diagram is not of much use. If someone is kind of looking at this diagram, there is no property and there is no methods, and if I want property and method like we showed, then it is only for one class. If we see the package and those diagrams, then it will be even difficult. This class is of no use. Okay. Second thing is that, so I mean it can be of use if I don't want the built-in property, that sometime it is required. Okay, so this is neat, but built-in property gone. Second thing is, okay, so if I see the connection class, it is not deriving from any class, but in reality it derives. Like if I open this class, like grep minus e class connection in user live Python 3 dist packages MySQLdb connections. Okay, so it derives from MySQL connection. MySQL is a kind of a class in a shared library, and it is generated through C code. So that much it cannot cut, but it is required because like it has a function called close, and it has function called commit. Those are not available here. They are available in those classes. So whatsoever, at least some hint should be there derived from the other class. Okay, so looking at these limitations, so we have kind of a wrapper over the PyReverse, another tool kind of written through us. So I can copy this tool here. So it is okay, so it is PyReverse.py, it's a Python file, and if I execute PyReverse.py, it prints the kind of help, and there are mainly fix and modify. So if there is a Python code or Python code and whatsoever, fix would work, and it first fixes the Python code because many instances we have Python code also. So first it fixes it, then we call modify to actually draw the diagram. So we'll proceed. So I can say Python 3 PyReverse user lib Python 3 dist packages MySQLdb. Okay, so this is what we want. Now we have to place package directory and package name separately, and I have to say fix. It fixed. It created a directory MySQLdb, and fixed code is available there. Now we'll execute this. Kind of I can write Python 3 PyReverse modify and MySQLdb, and then I can say in MySQLdb I want connections.connection class. Okay, so MySQLdb, it will generate kind of a package diagram, and it will highlight the connections.connection. We'll try. So it is parsing all the files it generated. Okay, so this is the package diagram, but so small it is. Okay, it has built-ins also. It has everything. In built-ins only we are not showing the kind of built-ins.object because it is implicit that everything is derived from the built-ins.object. Otherwise, this is complete package diagram, so small. And all the classes are a skeleton. Only what we need is kind of a big class, and inside that left side is attributes, right side is left side is attribute, right side is method. It derives from MySQL.connection. That was missing. Okay, so that much information we provide in a package diagram. So this is a package diagram. Okay, there is no separate diagram. This is the only thing in package diagram. So we don't need -k and -c and then colorize option, non-colorize option, show built-in, not built-in, nothing. Means if you just run this full package diagram highlighting a particular class will come. So in a MySQL package, classes are interrelated like this, and whereas highlighting the whatever we want. So this is kind of a first analysis. We can analyze the software quickly in this fashion. Okay, so as we can see that in classes, I think we removed everything. So what we had generated, the okay, so like for connections, or if I generate the kind of package diagram, okay, so class.pdf, if I browse, okay, it is big, because every class it is showing property and everything. There is no parent class of connection. That is also missing. Okay, there is no parent class. So, and for every class so if this package diagram is big, then it will be kind of problematic. So this is smaller in kind of comparison to that. This is quite small. Only highlighting this, and library level inheritance is also available. It derives from MySQL connection. Okay. Other thing here is we can generate kind of full classes. There is no way we can generate full classes of the packages. Here we can generate full classes of the package. Okay, so that's it. So we'll generate and we'll see. So I'll say Python 3 PyReverse and MySQLdb. I need not set Python path because anyway package is in the current directory only. Okay. Modify MySQLdb. Now it would generate all diagrams. So before we do that, we'll remove everything. And now we'll say PyReverse. Okay, we removed that also. So we'll copy back. So Python 3 PyReverse. Okay, modify and MySQLdb. There are 22 classes and it is iterating for each classes in the package, and it is generating complete class diagram of the MySQLdb. So this is kind of something if someone is starting work on MySQLdb without knowing what it is. So you can just run this command. Some 3-4 words are there and it is done. Okay, so there is a file directory called output that is generated, and we can see there is a file called PyReverse. So we'll see this file, and it has 22 classes and all class diagram is available. There are many things here. Okay, if there is a MySQLdb exception database error is the class that we can see. Then it has full inheritance, including built-ins, built-in exception, built-in base exception, everything is there. And list of derived classes is also there. That is missing in kind of PyReverse. It doesn't list the derived classes. Derived classes are also available in green color. Means just generate this for a software and you have everything in your hand. Okay, so it is searchable. I can search for the dot connection, and this is a kind of a main class dot connection, and it derives from connection. It contains cursor, and then cursor is derived from 3 classes, and then error is derived from MySQL, and built-ins are also available. So kind of this is a kind of a book that you can just keep in mobile, and you can just in leisure time you can browse and you can see the architecture. Okay, nothing is derived from the connection, whereas other classes things are derived. Like if it is a base cursor, okay, if it is a base cursor, then there are many things that derives from the base cursor. Cursor, dict cursor, SS cursor, SS dict cursor. So nice it is. Okay, so in one class diagram someone can see package complete. Okay, so dict cursor, SS cursor, SS dict cursor, DB API set derives from frozen set. Okay, Mr. Cursor, famous cursor, that is kind of, it derives from three classes: base cursor, result mixin, and rows mixin. Okay, base cursor is kind of a top class. So this is the kind of a panoramic architecture. Okay, so now if we see the kind of a lab session, then we have covered kind of how package and class diagram relate to each other, and how diagram can be generated at each level. We saw the MySQLdb, like connection contains cursor. In reality we saw, and they work through MySQLdb. And whereas in theory session, we installed PyReverse, and then we installed MySQLdb, and then we executed the PyReverse. So that is the scenario. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.